Students, today we're going to synthesize acetanilide. The first thing you actually have to do when you're prepping is have one student start preparing boiling water. We're going to need a lot of boiling water today. This one is a fluted filter paper in a stemless funnel. Let's see if I can show you the stemless funnel. See, it has no stem. We need it to be boiling hot by the time we do the hot filtration. The watch glass helps it to keep hot, and then the other one is our boiling water. I pre-measured the quantities we need. This is 2 milliliters of acetic anhydride, 10 milliliters of glacial acetic acid, and approximately 2.2 milliliters of the aniline. The two organic reagents are the acetic anhydride and the aniline. Those are the two we're going to weigh. In your stoichiometry, you need to do a stoichiometric ratio for the aniline of at least 2 to 1 because of the acid-base reaction that competes with this. And so hopefully we'll have enough aniline at a 2 to 1 ratio when we do it. So first step, we're going to weigh this compound and pour it into our reaction mixture. I'm going to first put the solvent in because we don't have to weigh it. So the glacial acetic acid is now inside. I'm now going to weigh this one, which is the acetic anhydride. Pour it in and weigh it again. Come with me. Are you ready to weigh?
Yep.
Okay. Hopefully it won't evaporate too fast. Right there. Okay, write it down. We're going to pour the acetic anhydride into the glacial acetic acid. Even if it reacts with the glacial acetic acid, it will just remake acetic anhydride. Now we're going to weigh it again to know how much actually went in there.
And we get the mass by difference.
Mass by difference. This is for your stoichiometry calculation.
Ooh, it smells wonderful.
It smells like vinegar. Okay, right there. Okay. Now we'll do the same thing with the aniline and the dropper. We're supposed to add the aniline dropwise, and we're going to lose some. So
how would you describe the odor of aniline?
Fishy.
Yeah.
Yeah, rotten fish.
I describe it as fishy nastiness.
Yeah.
You guys are missing out.
Bad fish.
It's going to evaporate too, is it?
Yeah, but not very fast. It'll
I
set.
think it's going to settle. There we go.
All
Right.
Write it down. All right, let's add it to the mixture.
Let me get a good view of this when you first add it.
It shouldn't be too yucky. Okay, so we're supposed to add this dropwise. You see it's kind of bubbling down in there. And I'm going a little bit on the fast side, trying to mix it as I go. If this was really good aniline, it would actually be 100% colorless, but we're going to worry about the color later when we do the decolorization step. To make perfect aniline, you have to actually distill it right before you use it. Okay, let's now weigh how much aniline went in there. And this one could be our other limiting reagent. Remember, his ratio is 2 to 1. Should stop. Right there.
There we go.
Okay, record that. All right. We are now going to put our joint on, which I previously greased. Make it airtight. Raise the thermal well, and we're going to reflux this for about an hour.
So, oftentimes in labs like this, I would have students do the setup first, then I'd lecture on it because of the waiting time.
There's a huge waiting time on this one. So we have our water running. It is mandatory. You need that to keep the water cycling. So that'll reflux We're starting our boiling. We have our activated charcoal ready. The only other thing we'll need is about 50 milliliters of ice water in here for the end of the reaction, which we'll do during the 1 hour of waiting. And cut.
All right.
Okay, we've been refluxing for an hour. We're going to now turn the heat off, let it stop dripping, and then we'll quench the reaction.
What is it focusing on? There we go.
How's the focus looking?
That's good. It was kind of almost pinkish on the cram, but
Yeah, it's actually an orange color liquid. That again is due primarily to the aniline impurities. We'll remove the color at our next step. I'm going to back up just a little bit. Can you still see that?
Yep.
Twist this over. All right. Once it stops dripping, we can disconnect, and we're going to pour the entire mixture into our ice water here, and it should immediately turn into white crystals if all went well. So first disconnect the condenser. That looks good. Now we're going to take, and again, because this is boiling hot, we're going to use the clamp and pour it all into here. Can you see this?
Yep.
And I'm going to do a rinse with boiling hot water.
Looked almost like a precipitate was forming, then it all dissolved again.
Yeah. We'll ice bath it next. Okay. So it looks like we've more or less rinsed everything out of our round bottom. This is a water soluble.
Oh, there
I'm
it
going to
goes.
stir it really fast,
Yeah,
and
you
you
got it
see
now.
it all crashed and precipitated. If you look inside, you'll see a nice precipitate. So I'm going to ice this for about 2 minutes and then do a crude filtration.
That fresh orange juice? No,
Fresh grapefruit juice.
Yeah, I think like pineapple maybe.
Might be pineapple. Okay. Let me remove all this equipment and set up while that's cooling up with my stuff.
I had a student tell me to stop comparing things to food because I'm teaching her lunchtime.
Well, all food is mostly organic chemistry anyway. That's a nice comparison. Okay, so we're going to ice it. We have iced our crude product. We have most of our crystals have crystallized in this aqueous solution. We're going to do a really fast crude filtration as soon as we turn on the suction. Oh, the speaker had contamination on it. So can you see that?
Yep.
All right. We don't have to take out all of the solid because we're going to recrystallize right back into the speaker. What we need is to rinse it one time. You see the nice brownish color? Our crystals are supposed to be colorless or white. So we definitely have a colored impurity mixed in with our compound. Okay, so I rinse that one time with pure water. We're going to wait for the
Almost dropped my phone.
suction to stop dripping. See the dripping? As soon as it stops dripping, we're going to transfer it right back into the beaker. And then we're going to do our hot boiling step. So I'm going to set that up so I can do it.
So it's still discolor. We still have to discolor it.
Yeah, so the discoloring step is mandatory at this stage. Okay. That stopped dripping. Let's transfer. Okay, so I'm going to transfer back in, and we're going to use boiling hot water. Boiling hot water will barely dissolve acetanilide. So it means it's an innocuous solvent. The problem is that boiling hot water has an incredibly high heat of vaporization and an incredibly high heat capacity. So it takes a while to boil and to evaporate, which will create a problem for us a little bit later on. Okay. Now this acetanilide lab is exactly the same material that we do in 241. We make the students actually repurify our products from 242. So looking down in, you see that? Most of it fell off in a clump. We're going to use this boiling water. I've been boiling the whole lab. And rinse out what's in here first. And if you see any sparkling, that's your product. The product does sparkle. So I always try to look for a reflection of light or any type of sparkling. Oh, there's a little bit in the corner. Use this, but you can see our product, even if boiling water, it floats. Well, there's some product right there. See? Don't want to lose any product. Here we go. Oh, there's another piece. There's another piece. It's hiding all over the place. This is why you rotate in the light. Come on, product. Okay, I think I got most of it. Now I'm going to try the boiling water one more time. Okay. Okay, you guys see anything? It's rotating in the light. I see something right there. Okay. Now this lab goes so well that sometimes we end up with over 100% yield for the simple reason that evaporating water off takes forever. So just like in 241, if we look at our crude product, you see the brownish color? We're going to have to do a decolorization. But before we do that, we have to bring everything to a boiling temperature, and we have to remove this piece of filter paper. Make sure none of our product is on the filter paper. Okay. The other good thing about this lab is you can always eat the stuff if you want to. It's 100% edible. Did you know that?
Yeah, it's a pretty similar structure to Tylenol.
Yep.
Yeah, Tylenol just has an extra OH compared to acetanilide.
Yeah. And when you eat it, it goes back to aniline and acetic acid. And our body takes all our acetic acid and turns it into acetyl-CoA and does all sorts of cool reactions with it.
You turn it to
The numbers aren't there. Yeah. Can you see that?
Yeah.
Okay, it's time to boil. So, going to switch places with my boiling water to this one. And ideally, once it boils, all the solid will dissolve. The colors will kind of coagulate as oils on the bottom. And we will see that in just a few minutes, as soon as that water boils. We have basically dissolved our crude. You'll see droplets of color on the bottom. There's a little bit on the side, but we have to decolorize now. So we're going to take this activated charcoal. We're going to add just a small scoop, and what it's going to do is grab all the coloring compounds and hopefully leave behind, so the small scoop. and it will leave behind in solution the acetanilide.
I want to make a comment here. So the main thing you want to think about with discoloration here is that yes, obviously you see the black, right? But the yellow brown is gone now.
And
We'll get rid of the black.
Okay, at the next step. So the next step, if you look inside this, I pre-prepared a fluted filter paper with boiling hot water, so it's boiling hot. And we're going to do a hot filtration right onto it using a specially made folded paper towel. I call it the cravat. You wrap it around so you don't burn yourself. Turn it so I can pour right-handed. And I'm going to put this, hold on, put this right here for a moment. I'm going to put this back on because we're going to need boiling water to remove our product. One of the hardest part of this lab is as soon as water cools off just a little bit, our crystals immediately start forming. And you'll see that our liquid is basically colorless, as Professor Amor said. You want to look down inside?
Yeah, it's pointing at this right now.
Can you see inside of here? So if I look down inside, even though this is boiling hot, I can already see sparkles forming on the paper. I'll move closer.
There you go.
Can you see the sparkles?
A little bit.
Yeah, if you catch the light just right, you'll see the sparkles are forming right along in here, right along the edges. You'll see some right there.
Over the way a little bit. Yeah, you saw them a little bit.
You can see them a little bit. Okay, anything that sparkles is our product. We want it to go through the filter paper. So I'm doing another rinse from the beaker with boiling hot water. I'm going to rinse this a couple times to ensure complete transfer.
Back it up a little bit again.
I'll let you do what you want.
Okay.
Okay.
I want to focus on.
Can you manually focus?
I may have to. I was focusing on the back speaker. Okay.
Let's get this out of here.
I smell vinegar.
Good. And I'm going to do a final rinse of this beaker. I think I've transferred all the product out. Give me one more rinse.
You don't want some boiling water to the filter paper too?
Yep, I'm going to. Okay, so I think I've transferred all I can from the crude beaker. It's now all in here. I look inside. I can see those edges are looking a little sparkly, so what I'm going to do is I'm going to squirt down the sides of the paper. Just again with boiling hot water. And the goal is we want all of our product down here in the filtrate. None of it stuck in the paper. And another goal is to not use too much water. So there's a fine line on too much versus losing all your product up in the filter paper. Okay, looks like I squared down. Now one of the things we're going to do at the very end after we collected our final product is we're going to re-examine this paper once it's dried and see how much of our crystals actually are still stuck in the paper. And so what you try to do at this stage, and I'm going to keep spinning it around so I can see the other sides, is the best you can Remove any crystals that you think may be stuck on the paper because the paper became too cold all of a sudden. Okay. And then we'll decide at the end of the lab if we did a good job filtering at this stage or not. Okay, I don't see anymore. I see a little bit, maybe right there. Nope, that's just the oil's jumping. I'm going to look behind the fold here because sometimes they'll hide in the folds. Okay. All right. I've done what I can. I'm going to put the watch glass on until it finishes stripping all the rest of the way. Then we're going to take this off and we're going to collect our final crystals in this aqueous solution down here that has boiling hot water. We're going to let that cool. So
yeah, I'm seeing some precipitate at the bottom there.
Is it already precipitating? That's a good sign. That's what we want to see.
I'm not showing you my camera though, but I'm seeing it from here. It's getting murky.
Okay, I think we're done filtering. We're going to let that cool. We'll spread that out on a paper towel later. So where do you see? Doesn't matter because we want it to form crystals now.
Oh no, that was just the light. Never mind.
Okay, so now it's just a matter of letting it cool. Turn off all our heat sources. We've dried our piece of filter paper and we're looking to see how many sparkles are shining. There's one big sparkle right here. I don't know if you guys can catch it.
Yep,
there's a little bit of sparkling there. So that is actually some of our product that got away. We didn't put enough hot water through the filter paper. It's really hard to see when the paper is wet because the sparkles just dissolve into the water. But there's a little bit, but it won't weigh more than maybe a tenth of a mil, or maybe 1 or 2 milligrams. Acetanilide is very lightweight, but we did pretty good. Now we're going to filter our final product. Okay. We've been icing it for 5 minutes. We're going to turn the suction on. Use ice cold water to filter with, and we're going to try to. Okay, we're going to try to take as much of that product out as we can and put it over here in the filter paper. First I'm going to pour off all the liquid, and then I'll start squirting in the crystal.
I usually have to finish this up for it and then pour all at once.
You want fast pour? Yeah, you can do that. But I got most of it, and if you look, the crystals are kind of a flat plate. They're really sparkly when they catch the light, and they almost look like snowflakes. Okay, so now the last step is to let the air dry this. We're going to leave the vacuum on for another 30 minutes, so this is going to. We're just going to stop it and come back, and hopefully the water will leave our product and we'll have a really nice yield. We'll have a nice percent yield and we'll have a nice melting point. Okay, we've been drying our products now for a half an hour. If we look down inside, you'll see they're nice, shiny, flat looking crystals. They have a bad habit of blowing away in the breeze. We are now going over to the scale to weigh our final yield. So let's take this with us very carefully, and our watch glass and our scupula. Okay, so first thing we have to weigh is the watch glass itself. Record that weight. And we need to transfer all of our product onto this watch glass and hope it doesn't blow away.
We made glitter today.
Yes, we did. Ah, it just blew.
Yeah, there's some on the bench too.
Don't say that. Okay, you'll see even this paper is sparkly with little crystals.
Yeah,
I don't know if you guys can see the sparkle.
I can see with my eye, but I can't see it. Oh, there it goes.
There it goes. You see the sparkle?
Yeah.
We're going to try to knock off as much of that sparkle as we can without scraping paper onto our product.
You ever seen the glitter bomb video on YouTube?
No, I haven't.
Mark Rover.
Glitter bomb.
Yeah, so
Did he fill up a balloon or what?
So he made this package that has a camera on each side of the box. That when you open the box, it starts a motor that sprays fart spray, and then it also has a spin the fan that shoots out a pound of finely ground glitter, and then the camera that will record your reaction. But it's hilarious though because people get the odor first, then the glitter happens. Oh, it's hilarious.
What odor does it have?
It's a fart spray.
Oh, so they get...
It's hilarious.
So it's a combo of two bombs at once.
Yes,
Is what you're really doing. A smell bomb and a visual. Okay, guys, look inside
Anyway.
in here. I can't get it all out. Can everybody see the sparkling? Can you see the sparkling?
Barely.
Barely. There's just a little bit of sparkling left. Most of it's on here, and again, I mentioned we don't want to accidentally blow it away. It's very lightweight crystals. Okay, this is going to be our final yield.
Make sure you get the weight by difference.
Right there. Record that.
All right.
Now for our melting point.
Get one last nice close-up of the product while we're in the light. Yeah, nice. Looks like glitter.
Yeah, it's a very pretty product.
Yeah, if you may remember that we did use acetanilide during the first melted point experiment. But it was one of the compounds anyway.
Yeah.
But then we recrystallized it later on.
In 241.
Yeah, and I think the reason why this is a really classic compound to use in recrystallization experiments. And I think the reason why it's so commonly used is because of how pretty the product looks when it's purified.
And how non-toxic it is.
There's that too.
Yeah, you can use it, make mistakes, spill it all over you, and not have to worry about dying.
That and the solvent's water as well.
Yep. Okay. We're gonna bounce this in a second, but
I don't think we even need to.
It basically went down pretty well. This is old-fashioned bouncing. Yep, that looks pretty good. Let's go take a melting point.
All right, so we're just gonna go ahead and set up over here. And okay, everybody, we're at the final moment of truth. This is our main assessment of purity today. We're not getting any spectra. So, yep, the expected melting point is what, 114, 115, that range? Yeah, so I set the start point here to 100. And we only have the one tube in there today. That's the one in the middle. So, as usual, enjoy the show.